Hey class, day 2 of factoring. We're going to focus mostly on a method that's called factor by grouping. But first we're going to start with some factoring review. So recall, if this is just a single x squared, you can start by just writing the parentheses because you know it'll be x times x. Then what multiplies to -4 and adds up to -3 would be -4 and +1. So it has to be x minus 4 and x plus 1. So that is a simple quadratic trinomial to factor. Now, if this was x to the 4th minus 3x squared minus 4, the only difference in our answer would be that it would be x squared minus 4 and x squared plus 1. And then x squared minus 4 would factor more to x plus 2 and x minus 2. But remember that the quartic and the quadratic factor very similar process to that. This one over here, 3x squared minus 12, you can take out a greatest common factor and you're left with x squared minus 4 if you divide out the 3. Then x squared minus 4 does factor more. Difference of perfect squares factors to x plus 2 and x minus 2. If our a value is not equal to 1, then we want to use the box to factor it. But actually this one, you can take out a 3. So x squared minus 2x plus 1. Then multiplies to 1, adds up to -2, be x minus 1 and x minus 1. So multiplies to +1, adds up to -2, -1 and -1. So that one actually did factor quite nicely. So I didn't need the box for any of those. Okay. So Dory just kind of gives you a visualization for factoring polynomials. First, look for a greatest common factor or greatest common multiple. After you do that, does it factor as a product of binomials? So that's like the x plus 3, x plus 6, or 2x plus 3, 2x minus 5. Or is it a special product? So we have difference of perfect squares or perfect square trinomial. And we also have difference of perfect cubes. So it might be one of those 3 formulas that we used. And then it might not be factorable. And then we have factor by grouping, which is what we're going to learn today. So factor by grouping is if it has 4 terms. So factor by grouping if we have 4 terms. So notice that here's our first example. So it's called factor by grouping because the first thing you do is you're going to group it. You're going to group the first 2 terms and the last 2 terms. Group the third term as -4x. So the minus goes with the -4x. So first 2 terms, second 2 terms. Then look for the greatest common factor for each group So for the first group, I can take out a 9 and an x squared. So I'm going to take out a 9x squared. So then if I take out a 9x squared from the first term, there's just an x left. And then plus, if I take out a 9x squared from 18x squared, there's a 2 left. And then close that parenthesis. Then my goal is to take out the greatest common factor from the next group, but I want what's left over to match this x plus 2. So notice that they're both divisible by 4, but I actually want to take out a -4, so I'm going to put -4 and then parentheses, and that's because when I divide both by -4, I'm going to get positive x, and then -8 divided by -4 is +2. So my goal is to make these parentheses, what's left, equal the same thing. Because now, if I look at this as a binomial, so this is my first term, this is my second term, these two terms have the x plus 2 in common. So I can take and put the x plus 2 out front, and just like divide this by x plus 2 and divide this by x plus 2, what's left over is 9x squared and then minus 4. So I'm factoring out an x plus 2, and I'm taking that x plus 2 and I'm moving it out to the front. And then 9x squared minus 4 is what's left. Now in this case, 9x squared minus 4 is a difference of perfect squares, a squared minus b squared. So it does factor further, x plus 2 times 3x plus 2 and 3x minus 2. So difference of perfect squares. Okay, let's do a couple more together. So group, include the sign with the second group. Then take out the greatest common factor from each group. So 3x cubed and negative 12x squared are both divisible by a 3x squared, which means that the 3x squared goes out front and you divide both terms by 3x squared. So 3x cubed divided by 3x squared is x, and then negative 12 divided by 3 is negative 4, and the x squareds cancel. Then take out the greatest common factor in the next group, keeping in mind that you want what's left to be the same as the parenthesis x minus 4. So I can take out I want to take out a positive 2 between 2 and 8. So if I want to take out a positive 2, I'm going to put plus 2 here. And then dividing both of these by 2, you're going to be left with x minus 4. And that was the goal, to make sure that these are the same. Because now those are the same, and I have two terms. This is my first term, this is my second term. Both terms have an x minus 4, so I'm going to take the x minus 4 and factor it out. So then it cancels from each group, and then what's left is the 3x squared plus 2. Now 3x squared does not factor any further. There is nothing that, if I was to, try to factor this, it'd have to be 3x squared and 2, so it would have to multiply up to 6, 3 times 2, but add up to 0 in the middle. I'd have to get my middle terms to cancel. You can't multiply anything to 6 that adds up to 0. And so this does not factor any further. Okay. Group. Take out the greatest common factor for each group. So the first set, I can take out an x squared. If I divide them both by x squared, I'm going to get x minus 5 left. And then the next set, I want to take out the greatest common factor, which is 9, because 9 and 45 are both divisible by 9. But I want my parenthesis to be x minus 5, so I'm going to take out a negative 9. So if I divide this by negative 9 and this by negative 9, it'll be positive x and then negative 5. So then my parentheses are the same. That's the goal when you factor by grouping. Then you have two terms, and they both have an x minus 5. So I can factor out the x minus 5, which means that essentially I'm dividing both of these terms by x minus 5, so that the x minus 5's cancel, and x squared minus 9 is left. And then x squared minus 9 is difference of perfect squares, so it factors more to x plus 3 and x minus 3. Okay, let's see, I did 3 examples and there's 2 left. I think I'll let you try these ones on your own, and then I'll plan to go through those, try these ones in class. So hopefully that was enough examples. If not, we can always get together and go through them as well.